Hello guys, in this video I am going to explain the solution of this question number 3 from chapter 10 of Engineering Circuit Analysis by Hayt, Kemmerly and Durnin. So the question says that we need to determine the angle by which voltage leads the current, and it is given that voltage is this and different currents are given. So for A it is given this. So for this type of a question where we need to determine which one is leading and which one is lagging and by what angle. So for this the approach is that suppose if we have like V1 equals to 10 cos 10t minus theta, or in general if I write in general just to explain the overall concept. So if it is like omega theta 1 and suppose the current I, if it is like instead of 10 let me write Vm Im cos omega t plus theta 2. Now to determine which one is leading and which one is lagging, there are two ways. One way is a waveform, like using the by drawing the waveform we can determine which one is leading and which one is lagging. So if for the cos, we know that for the cosine the waveform it starts from this, right? It starts like this, means this is 0 degree if it is omega t, and this is the graph for V. Then if it starts from z, this maximum is achieved at 0, then this is at pi by 2. This maximum it is at pi, it is at pi, this is at 3 pi by 2, and then again the maximum, positive maximum, it is achieved at 2 pi. So from 0 to 2 pi the one cycle is completed, this we know. Now over here this graph it is for cos or Vm cos omega t, means this is the maximum Vm and this is minus Vm. Now over here if there is a phase, if there is a phase of theta, right, then it means that this wave shape is going to shift either towards left or right. So where it is going to shift, if it is plus theta, so the shifting, to check the shifting if it is on the left and right, simply what we do, we substitute omega t plus theta equals to 0, omega t is equals to minus theta. So it means that this waveform it is going to shift to at minus theta, means at omega t equals to minus theta. What it means, that this 0 at this 0 maximum positive is there, right? So this maximum positive will be achieved at omega t equals to minus theta. So suppose if theta is, let it be, if theta if it is 45 degree, so it means omega t equals to minus 45 degree, and minus means that the shifting it will be towards the left side. So if this angle is 45, then it means that this 0 it will be achieved over here, and our waveform like maximum will be over here. So our waveform it will be something like this. Okay, so it will be a proper cosine waveform. So the main thing that we need to understand over here is that the shifting, because it is omega t equals to minus 45, so the shifting is towards the left, and since the shifting is towards the left, so you can note that for this red one has achieved the maximum before blue one. So we can say that red leads blue by theta or by 45 degree, because the distance between the blue and red it is 45 degree. So red is leading, or we can also say that blue lags red by 45 degree, or we can also say that since red lags blue. Why? Now since in actual red leads blue. So if we are writing lags, so simply we need to write the angle with minus. So this minus will indicate that whatever we have mentioned over here, in actual it is opposite. So since over here it is minus, so it means in actual it will be leading, right? So in this way, simply by equating by whatever angle we is given, simply we can put that, we can equate it to 0, and from there we can get what is omega t, and whatever is the omega t, accordingly we can draw the graph. Or in a more simple way, instead of drawing the graph, suppose over here instead of theta 1 and theta 2, let me put some angle, let it be 20, let it be 50, right? So over here, simply what I can do, I can first equate this one. It is omega t equals to 0, so means omega t is equals to minus 20, and for this one omega t is equals to minus 50. So what I can do, I can omega t equals to minus 20, so it will lie over here, so it is v. And for the current, omega t is equals to minus 50, so minus 50 will be over here, so current is this, right? So simply current comes before v, so I can say I leads v by what angle? Now this is minus 20, this is minus 50, so this angle it will be 30, so by 30 degree. So 50 minus 20, it will be 30 degree. So in this way I can get the answer. So now coming to our question, coming back to our question, the question says that it is given that v1 is this, so we can equate 10t minus 45 equal to 0, so our we get 10t means omega t is equals to 45. So just we can plot that, let this is 45 and this is our v. Now coming to the current is this, so over here 10t is equals to 0, so means our omega t is equals to 0 means it is starting from 0, so this is our 0 which is current. So from this you can see that current leads v, so we can say that I leads v by what angle? The difference between the angle, it is 45 minus 0, it is 45, so by 45 degree. But the question is asking that we need to determine, it is v1 leads i1, so we need to determine the angle. So it means we need to write that v1 leads i1 by what angle? So over here, since in actual i1 is leading, so if we are writing that v1 leads, then simply we put minus sign, so it is minus 45 degree. So this is the answer to the first question. So for the first question, the answer is minus 45 degree. Now the same thing can be done using the phasor diagram. So what is phasor diagram? So let me also explain that. Now as we have considered this thing, let me erase a little bit. Yes, so in the phasor diagram, it is a graph, and on a graph, like it is 0 degree, it is 90 degree. We know this from the trigonometry, it is 180, 270. We can also say it as minus 90 or minus 180 or minus 270, and this as 360, right? Now over here, when we talk about how we are going to draw a phasor, this is a phasor diagram. Right, so when we want to draw the phasor of v1, so in the v1 simply we are going to look for the phase angle, so it is 20. So what we are going to do, we are going to draw a vector at an angle of 20 degree, and the length of this vector, it is going to be vm, right? So this is a vector, this is a phasor for v1. Now similar to this, we are going to do for the eye. So for the eye, the angle phase is 50, so we are going to draw the phasor For I, the length of this vector, it will be Im, and this is angle is 50, right? Angle is 50, or let me put it over here, 50, right? Now from this phasor, from this phasors or the vectors, you can see that this blue line, like if we move in this direction, in the anti-clockwise direction, so the blue, it is leading the green, means blue is ahead of green. So we can simply say that blue leads green by what angle? Now the angle difference, it is 30 degree. So we can say that it is leading, blue leads green by 30 degree, right? So simply it means that if we are given this type of a expressions, so simply we can draw the phasor vectors, right? And the difference of the phasor, like the angle difference between the two phasor vector, will give us the angle of leading and lagging, and the one which is ahead, it means that the one that is ahead, it is leading. So now applying the same concept for this question, for the first one itself, for which we already got the answer as minus 45. So if this is my phasor, right, now over here the angle is minus 45. So for the voltage, I will draw a phasor at an angle of 45 degree. So this is our V. Now for the current, it is the phasor angle is 0, because we can express this as 5 cos 10t minus 0, right? So the angle is 0. So I will draw another phasor at an angle of 0 degree, and this is our I. Now you can see, moving in an anti-clockwise direction, I is ahead of V. So we can say I leads V by what angle? The angle difference between the two, it is 45 degree. 45 degree. And now since we need to answer in this form, V1 leads. So V1 leads I1 by, now because in actual I1 is leading, so we can put minus to the angle. So you can see we got the same answer using the phasor diagram also. So in this way we have two approaches, and this phasor diagram is also a very easy method. So now applying this concept of the phasor and the wave, this wave shape, to the second part of the question. So over here in the second part, let me erase this. Yes. So in the second part, again the V1, it is at this angle 45. It is our V1. Now over here the angle is minus 80. So what I will do? I will have the current over here. So this is our 80, right? So this is I1. The difference between the angle, it is 80 minus 45. So it is 35 degree, right? And over here V1 is leading, like V1 is ahead of I1. So simply we can say that the angle is 35 degree. So V1 leads I1 by 35 degree, right? Using the a different approach, this approach. So for this approach, let me erase over here. So for this approach, as I told you, I will just plot. I do not need to draw the complete waveform. So for the V, it is 10t minus 45 equal to 0. So 10t is equals to 45. So it means our waveform starts at 45 degree for V1. Now for this current, 10t is equals to 10t minus 80. So it will be 10t equals to 80 degrees. So our current, it will starts from here 80 degree current I1, right? Now V1, from this you can see V1 has achieved before I1, so it means V1 leads I1 by what angle? The distance of this. So 80 minus 45, it is 35 degree. So we get the same answer. Now coming to the C part, it is, let me erase this one. Now it is minus 40. Minus 40 means that the current, it will be over here. This is 45. So it means over here, this current is leading, right? By what angle? This will be the angle. It is 5 degree. So current is leading V1, but we need to answer in this form. V1 leads I1. So it means the answer will be minus 5 degree. Going to the next one, D part, it is plus 40. Plus 40 means that again drawing a phasor, it is 40, this is I, so the total angle is 85, right? And current is leading, but in actual we want to answer in this form. V1 leads I1 by what angle? By minus 85 degree, because in actual V1 is not leading, I1 is leading, so angle will be in minus 85. Now E part, it is, now E part is tricky in what sense? That over here it is not cosine, it is sine, and V1 it is in cos. So remember, when we are comparing the angle, we need to check if both current and voltage, if both are either in cosine form or in sine form. But over here, since the two are not in the same form, so we need to convert one into the another form. So let me convert this sine into the cosine form. So using the trigonometry, we can rewrite this expression as cos 10t minus 19 minus 90. So you need to check trigonometry if you do not understand why I put minus 90. But simply if I add or if I subtract 90 to this angle, then this sine will become cosine, right? So it means it is our 5 cos 10t, it is 10t. So 10t minus 109 degrees. And now we can compare. Now our it is, angle is 109 minus 109. So it means, again redrawing this, our angle, it will be this 109. So the difference between the two angles, it will be 109 minus 45. So it will be 64. So it means that the difference, angle difference between the V and I, it is 64. And over here V1 leads I. So over here for this one, the answer is 64 plus 64 degree. So in this way, we can determine the phase angles between the two waveforms, and we can also determine which one is leading and which one is lagging. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.